after we had a completed 3D model that was reflective of Chadwick Boseman in the suit, and we were pleased with its pose and the silhouette, we had to figure out how we were going to build it. Imagine trying to get into a spandex suit, but you can't bend at the waist, and you can't bend at the elbows, and you can't move your hands, and you can't move your neck. We had to figure out how to get all of the limbs into the garment through the relatively small apertures that were sewn in for an actor to climb in or out, and eventually settled on removing both arms so that those could be preloaded into the garment, followed by the body, and that would allow us to dress it in, so to speak, the correct order.
Typically in outsourced mannequins, the joints are attached with metal hardware, and that hardware can be very flimsy sometimes, and it can also be very hard to connect under the clothing.
When you have a connection purely just at the shoulder, you'll often see that through the garment. You'll see a slight dip. One of the things that we really wanted to do was not only create something that was sturdy, but something that when it was fully put together, you could not tell where the seams are.
Software that I used allowed me to take the sculpted model that Willow produced and perform a variety of highly precise operations on it, to slice it to specific tolerances, to add joinery in the limbs, or to cut into the interior portions to add additional structure. It also allowed us to part out the model into all of its component pieces to be produced by our CNC router.
CNC, it stands for Computer Numerical Control, and it's equipment that is driven by a computer. It runs on G-code, which is essentially a text file that's created from a CAM software, and CAM stands for Computer Aided Manufacturing. The CNC router, it's essentially a flatbed table that's got a moving gantry on it that moves back and forth across the work envelope of the table. And there's a machine head that also moves back and forth on the gantry, and it's got a cutter in it that does the actual carving of the three-dimensional form of the Black Panther mannequin. I looked at the initial model. We sort of discussed how it was going to be sliced up into the layers. We were using a 2-pound density polyethylene foam called Ethafoam. It's generally a good form for conservation mannequins. It's relatively inert. It's the standard for a lot of different museum mounts and also mannequins. The bits are a cutting tool. They look very similar to a drill bit, and they can either have a rounded end or a flat end, or they can have a pointed end like a drill bit. For more sculptural things that are organic in nature, like the Black Panther mannequin, I used a rounded end or a ball end mill to do the actual curved contours. I used 2 different tools, and our CNC router has an automatic tool changer on it. So I built that right into the programming. So whenever the machine was done using one tool, it automatically changed out to the second tool for doing the remainder of the 3D carving.
Willow and Laura had gone to very great pains to just sculpt out certain parts of the limbs and certain parts of the torso to have attributes that they thought would best suit the presentation of the costume. Assembling that, fairing those down, I wanted to be as true as possible to what the original intent was. So I wanted to be careful not to remove too much or to leave a little bump where there wasn't supposed to be one. So there were probably about 60 pieces all together in the foam. Before we glued anything together, we actually assembled the whole model with pins so that we could be sure that we had everything sort of mated up in its proper form. We used this conservation-approved hot glue, so there was glued together with a hot glue gun. So you have a very small amount of time to get the glue on, and then to get it in its proper orientation and pressed together. The surfaces have to be firmly held together because the heat of the glue actually causes a little bit of air release from the foam, and it will cause curling and it will cause a little bit of warping. The last part of the assembly process was actually building a metal structure made out of aluminum. When Willow and Zach helped with the undressing, and they sort of experienced the tension of the fabric, they thought it was best that maybe we put an armature in there just to make sure that over time there wasn't any deformation in the torso section, because they thought that's where the most tension was. We did make a simple armature which ran down both legs and up through the neck. One really thing that actually sets this, and has been experimental, but sets this mannequin apart is the joints. And we've been experimenting for a few months with the idea of actually cutting a joint in the ethafoam, much like one would cut a dovetail construction for wood, and pressing the two parts together and actually relying on the strength and friction of the joint to hold the limb. We actually exceeded our expectations wildly. I think we're onto something now where we can pose and construct mannequins in a way that support poses that just can't really be done very suitably without complex mechanical hardware situations. And in this case, it's really just foam, the foam holding itself with friction. So we're very excited by what we've discovered, and very excited to keep working with that idea to see what else we can accomplish with it.